Alright, today we're going to be learning about factoring polynomial expressions. Now, we've already done a lot of factoring. Some of this is going to be review and some of this is going to be new. Now, goal 1 says finding a GCF. So example 1, really directions are the same thing. Find the GCF, or greatest common factor. Now, notice the directions do not say to factor this. I am simply finding a GCF. So let's just do what it says. I have an x cubed, a plus 4x, and a 3x squared. So clearly I can't factor out a number because I'd have a 1, a 4, and a 3, and I can't find a number that goes in all three of these. But I do have a variable in each term. So whenever you're finding a GCF, the variable with the lowest power can be your GCF. So I have an x to the first, x squared, and x cubed. So my GCF is just x. Alright, and that problem's done. The second one, 2x to the 9th minus 10. Now I don't have an x on this term, and so I can't use an x as a GCF or a variable. The only thing I have is 2 goes into 2 and negative 10, so my GCF will be 2. And so that problem's done. It's a couple of quick GCF problems. Notice again, I wasn't really factoring, I was just finding a GCF. Alright, now we're going to factor. Factoring the sum or difference of two cubes. Sum of two cubes, difference of two cubes. Now, we have factored the difference of two squares and found that the sum of two squares wouldn't factor, but in this case the sum of two cubes or the difference of two cubes will. Now I'm going to make a little box right here and write something in it, and then I'll erase it. I just want to remind you of a couple of facts that'll be useful here in a second. If I take the cubed root, or actually let me do square root first. If I take the square root of x squared, and we normally don't write this 2 here, but that equals x, and so the squared and the square root undoes the squared. Well, for similar reasons, if I take the cubed root of, say, x cubed, wouldn't that make sense that I would also get x? And so this 3 will cancel that 3 and the x comes out. Alright, so now I'm going to erase this because I don't want to confuse you in other parts of your notes, because it really doesn't have to do with part A or B. I just wanted to put that there because it was a space to write it. Alright, now, so I'm going to create the sum of two cubes. So this is a formula that you're going to have to memorize. And so if I have a cubed plus b cubed, alright, what is that going to factor into? Well, it'll be equal to, now this is the sum of two perfect cubes because it's a cubed plus b cubed. Well, I'm going to take the cubed root of a cubed. Now write that here, at least this first time. Cubed root of a cubed is going to give me a, and that's what goes in that spot. So I take the cubed root of a cubed, and that goes there. Now, if this sign is plus, this sign is plus, and then to get this other spot right here, I'm going to take the cubed root cubed root of b cubed, because this is a b, and I'll get b here. Alright, so that's how I get those two spots, and that's why I kind of reviewed, you know, the square root of x squared or the cubed root of x cubed. Now, this next piece, once we have this, and there's a little memorization here, this piece, I don't look at anything else here or here, I'm just looking at this now. And so I take whatever's here, this a, and I'm going to square it. Alright, then I'm going to multiply this a times this b and switch this sign. And so that's going to be minus a b. Then I'm going to take whatever's here, this b, and square it. And that's how you factor the sum of two cubes. Now let's factor the difference between two cubes. It's very similar. I'm going to create a difference of two cubes now. A cubed minus b cubed. And now, the only difference here is instead of a plus for a sum, I have a minus for a difference. Alright, now this is going to factor very similarly. I'm going to take the cubed root of a cubed, which is just a. And I wrote it here, so I'm not going to write it again. If this is a minus, this is a minus. I'm going to take the cubed root of b cubed, which is b. And then this trinomial here that's multiplied together is going to take this a and square it, multiply these two together, and again switch the sign. So it's the same procedure. I'm going to take this and square the b. and get b squared. And so that's how you factor sum or difference 2 cubes. Now, this here will not factor anymore. Same as this trinomial. So once you're at that step, you cannot factor any further. Now, we always try to factor completely, especially when something's squared. The other thing will happen with this particular step is that if I try to solve these, and we're not solving today, but in the future we're going to solve by factoring, these particular trinomials will always give you imaginary solutions. So this and this. Alright, let's go ahead and factor with variables and numbers. Now, before we get started, I just want to remind you how to take the cubed root in your calculator, and because this has to be a perfect cube, and so does this. Now, x cubed is automatically a perfect cube. I'll take the cubed root of x cubed and get x. But what is the cubed root of 27? Alright, if you've forgotten how to do this in the calculator, I'll show you real quick. It's math. So you hit your math button, and then see this little 3 right here? It's number 4. Alright, so this 3 for the root is cubed root. So I'll hit 4, and then all I have to do is type 27 and hit enter. If I get a whole number, that's the cube root. That's the answer. The cube root of 27 is 3. If I get a decimal, it's not a perfect cube, and I really shouldn't be factoring that problem using this method. Alright. So, in this case then, I'm going to factor this first part like we did just up here. And let me lower this. Oop, wrong way. Oh, a little too far. Sorry about that. Alright, there we go. So this part right here, I'm going to take the cubed root of x cubed. In this case, it's x. It's very similar to this step. Cubed root of a cubed is a. This is a plus, so this stays a plus. And the cubed root of b cubed over here is b, which is this step. So the cubed root of 27 is going to be 3. Now, once I have that, I'm going to use that to factor the rest of this and use this step. Alright. Now, this, I just take whatever's in this spot and square it. So square this, which is x. I'm going to multiply these two together and switch the sign, just like this says. Multiply these two together, switch the sign. Then I'm going to square the 3, which is what this says to do right here, b squared. So plus 9. Now, like I said up here with this trinomial here, even though it has x squared, will not factor any further. If I try real quick, numbers that multiply to 9 add to -3, you will never find those numbers. Alright? So this problem's done. Alright, let's factor this one. Now right away I notice 16 is not a perfect cube and 2 is not either. If you need to check that in your calculator, it won't work. Alright, you'll get a decimal if I try to take the cube root of 16 or the cube root of 2. But, and I failed to mention over here, although it wouldn't have helped us, I try to factor out a GCF all the time, right? I always try to factor out a GCF, but there isn't one here. However, there is one here, right? There isn't a variable that I can factor out, but I sure can factor out a 2. So if I factor out a 2, because 2 goes into 16 and 2, I'm going to be left with 8x cubed minus 1. Now this turns out now, after I factor out this GCF, that I do have a difference between two cubes, which is this up here. 8 is a perfect cube, x cubed is a perfect cube, and 1 is a perfect cube. So when I factor this, now do not lose the 2. Your GCF, although sometimes students factor it out and just forget it and don't write it in the next step, has to be there. Right, now this is like my a right here, or a cubed I should say, sorry. This right here is like my a cubed. I'm going to take the cubed root of it. But there's two things here. The cubed root of 8 is 2, because 2 times 2 times 2 is 8. The cubed root of x cubed is x. If this is a minus, this stays a minus. And the cubed root of 1 is 1. So I just did this step, a cubed, took the cubed root of it, b cubed, took the cubed root of it, and kept this negative, negative. Now from here, This 2x, I'm going to square it. So I'm going to take whatever's here and square it. Now, I'll write this up here a little bit just to remind us. When we square that 2x, which is right here, you square the 2 and the x. Very common mistake with this type of factoring. So it's 4x squared. Now, now that I have that, I'm going to multiply the 2x times the 1 and switch this sign. So it's going to end up being plus 2x. And then I'm going to square the negative 1 plus 1. And that's completely factored. Again, if we try to factor this further, it will not. Alright? Alright, we'll circle this answer because it's done. Alright, let's move on. Alright, our next goal is to factor by grouping. Factor each polynomial completely. Alright, so when I factor by grouping, I'm going to group these two terms, I'm going to group these two terms, and I'm going to factor a GCF out of the first two and the second two. So I can get an x squared out of here, and that leaves me with an x minus 1. Alright, and that's because x cubed over x squared is x, and negative x squared over x squared is negative 1. Alright, if there's a plus here, I factor a plus here. Now, this already matches that, and that's why I have to factor a 1 out of here. I know it's a little strange just to put a 1 there, but I need to know what goes with my x squared. So my last step is x squared plus 1. Hopefully my last step. That's one factor. And then this x minus 1 matches, and so that's my other factor. These two have to match for this to work like this. Alright, now, x squared plus 1. I should always see if I can factor further. This is a sum of two squares. There is no way I'm going to be able to factor this. Now, we know that x squared minus 1 would actually keep going into x plus 1, x minus 1. But an x squared plus 1 will not factor further, so this is done. And the key to this step is this piece right here must match this piece. Alright? Either you made a mistake from here to here, or it's not factorable. Alright, let's move on to the next one. We're going to factor these two, and well, actually group these two and group these two. So, factor by grouping, we're always going to group the first two terms and the second two terms. And again, over here, first two terms, second two terms. And factor a GCF out of each. Now here, I can factor out an x squared. Now, it's not always going to be x squared. I know in these first two problems it was. Alright, now what's left here is an x minus 2, because x cubed over x squared is x, and negative 2x squared over x squared is negative 2. Whatever sign is here is going to end up right there, always. Same as this was a plus and that was a plus, this is a minus, this is a minus. Now I can't factor an x out of this one, but I can certainly factor out a 9. And negative 9x divided by negative 9 will become x. And 18 divided by negative 9 will become negative 2. And, alright, this matches this. So that's one of our factors. And it's really important that they match. So my other factor comes from this and this. So we simply factor out a GCF out of our two groups that we split them up into. So I get x squared minus 9 times x minus 2. And whoa, look at this. Now, over here I had x squared plus something. Here I have an x squared minus something. As long as this is a perfect square, now some of us realize this pattern goes x plus 3, x minus 3. Or I'm looking for numbers that multiply to negative 9 but add to a 0 x. Alright, because there's really no x term. So 3 times negative 3 will give me the negative 9, but a 3x minus a 3x will give me a 0. So that factors nicely. And then I cannot forget this x minus 2. It's still there. Now that I don't have any squares and it can't factor any further, my factoring is complete. Alright, I want you guys to have C and D done for us in class. Alright? Have a nice day.